This is a reminder video about the definition of a sheaf. Now, if you're watching the Etal series, I'll assume that you have some interest in sheaves, so you probably already know what the definition is. So this video is just meant to be a short way of jogging your memory. So what is a sheaf? Well, a sheaf is a place where you have descent for free. So what does that mean? Let's let X be a space, and let's let F be a presheaf on F, be a presheaf on X. So when is F going to be a sheaf? Well, we say that F is a sheaf when the following conditions are met. When, here are the hypotheses, I'm about to give the hypotheses, it's going to be 3 for alls. So, when, for every U inside of X, and for every open cover, sorry, U is an open set inside of X. So for every open set U inside of X, and for every open cover UI of U, and for every collection SI, where SI is inside of F of UI, and the restriction of SI to the intersection of UI and UJ is equal to the restriction of SJ to the intersection of UI and UJ. So given this setup, for every open set U and X, for every open cover UI of U, for every collection SI that agree on the restrictions, we have that there exists a unique S inside of F of U such that S restricted to UI is equal to SI. So F is a sheaf if for every open set U inside of X, and for every open cover of U, and for every collection SI that satisfies this matching condition, there exists a unique element S that induces all of these SI. So one kind of snappy way of saying this is that for a sheaf, consistent local data is equivalent to global data. Consistent, meaning this agreement on restrictions, consistent local data is equivalent to global data. So the local data are these SI, saying consistent means this condition, and the global data is this S. So descent is automatic on sheafs. So let me briefly mention that there's a way of saying this exact same definition slightly more categorically. I mean, there are lots of different ways of rephrasing this definition, but this one that I'm about to give is not conceptually different. It's just a way of translating these exact conditions into a little bit more compact expression. So the above is equivalent to the following. So given U inside of X open and a cover UI of U, the diagram, and this is going to be a diagram in the target category of F. So for all of the Etal videos, I think I made the target category sets. We're always talking about sheaves and presheaves of sets. The following diagram this guy is an equalizer. If you take the time to translate what this means, this condition will be exactly equivalent to the one above. So I'm just saying this because this diagram that I've drawn below is often given as the definition. I just wanted to relate this definition to the one that I gave up here. So this is for people who've seen this definition down here and are wondering how it relates to this one. So if you haven't seen this definition down here, let me just tell you briefly what these maps are. This is the sort of obvious restriction. And you can guess what these are too. This first one is going to be restriction onto restriction of the j part, and this first one will be restriction of the I part. Okay, so that's what a definition of a sheaf is.